This lesson is part of a series of training videos where we will look at a specific product in a specific installation, comparing our installation instructions and good practice with actual conditions on a job site. The primary goal is to help you become more familiar with our products, enabling you to tell if they've been installed correctly and if they're doing what they're supposed to be doing. Along the way, we'll also discuss what's important for when we need to determine if something is close enough, what's dangerous for when we need to bring something to the contractor's immediate attention, and why our products are used the way they're used. These videos will assume you're already somewhat familiar with the products being discussed. If you haven't already done so, please take some time to watch our other product training videos that go into detail on our various products, features, and components. Vibro-Acoustics creates noise control solutions for the HVAC industry addressing both airborne and structure-borne transmission paths. Our vibration isolation products help mitigate equipment vibrations that could cause noise problems in buildings. In this lesson, we will look at flexible metal hose connectors for hydronic pumps on vibration isolators. In late 2016, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called Daniels Waterfront South, a mixed-use condo and office building. The mechanical penthouse of the East Tower includes various pieces of equipment including base-mounted pumps. This group is the cooling water pumps, and this group is the condenser water pumps. Here's a picture of the condenser water pumps. As required by the project documents, the pumps are supported by concrete inertia bases on open floor springs and have flexible connections on both the suction and discharge piping. We'll go ahead and take a walk around the pumps, focusing on the flexible metal connectors, and then look at their datasheets and installation instructions. After that, we'll take a closer look at the flexible metal connectors on the discharge pipes and discuss what we should be looking for during a site visit. This is the suction pipe bringing water from the cooling tower. It is supported with vibration isolators and includes a black twin-sphere neoprene flex connector, which we will discuss in a separate training video. The two end suction base-mounted pumps each have their own flexible braided metal connector on the discharge side. The pumps are secured to concrete inertia bases supported by 2-inch deflection floor springs, which are also discussed in a separate training video. Here are the pumps and flexible connectors as seen from the other side. We'll pause here and take a look now at the datasheet and installation instructions for these flexible connectors. Flexible connectors come in various different materials and configurations. The datasheet shown here is for braided metal hose flexible connectors made with stainless steel and with various end conditions for different attachment methods to adjoining pipe, including sweat or brazing connections, grooved pipe connections, and flange connections. Threaded pipe connections are also available. This project used FCSS6GR flexible connectors with stainless steel braid and 6-inch grooved pipe connections. We can read in the table that the maximum lateral offset is ½ inch. That is the most that one end of the connector is allowed to be off-center from the other end. This is something to look for at the job site. Moving over to the installation instructions now, we'll focus on things we can check during a site visit. The first is to inspect the connector for any apparent damage. Are any of the wires in the braid frayed or cut? Any damage to the connector ends? We'll need to make sure the connector is not compressed or stretched or bent or offset beyond the maximum allowed offset. It should have adequate support, not supporting any weight other than its own. It is also important that the connector not be twisted. The instructions say to avoid torsional stress and to not put torque on the connectors. And of course, any shipping restraints or bars or blocking should have been removed. These are often tack welded to the braid collars on either end and are easily cut off once the connectors have been installed. So looking once again at the flexible connectors, we'll gray out the background to focus on these and make some observations. First, is there any visible damage to the braid or end fittings? In our walk around and close-ups, we did not observe any frayed wires or obvious signs of damage from impacts or welding splatter, so these are okay. Second, are the connectors compressed or stretched or bent or offset beyond their allowed maximums? For compression or extension, we can measure the distance from the middles of the adjoining grooved couplings to check against the length as shown in the datasheet, which in this case was 18 inches. We can also look for bulging or contraction in the middle of the flex connector. In this case, there is none. The center lines of the pipe above and below the flex connector are collinear, so these connectors are not bent and they are not offset, which is actually a common problem with these connectors. In this case, any offset is not enough to be visibly noticeable, which is close enough to deem them okay. Third, are the connectors adequately supported? Typically, this is only an issue where the connectors are installed horizontally. The short pieces of pipe below the connectors here are supported by the pump flange below, and the pipes above these connectors are hung from the structure above. Since these connectors are installed vertically, and since there is no evidence of compression or stretching, we can readily assume that these connectors are adequately supported. Fourth, are the connectors twisted or torqued? Next to the excessive offset, twisted connectors is perhaps the most common problem. You can look at the braid pattern and see whether the connector is twisted. The one on the left here appears to have a slight curvature in the braid pattern, but it is very minor and can be deemed close enough to be okay. And fifth and finally, were the shipping restraints bars removed? This one could have been answered first, as there are evidently no external restraints or bars left on the connectors, which means they are free to flex as they are intended to. So these are okay. And since we've answered all 5 questions with okay, the overall assessment of these flexible connectors is okay. I'd like to take a moment to discuss the use of flexible metal hose connectors. In most cases where they are installed on pumps as seen here, they can only provide a degree of stress relief for the pipe connections that may be created during pump startup. Flexible metal hose connectors are very stiff and can only flex slightly side to side when installed vertically as seen here. They cannot provide any absorption of vibration that moves along the axis, or vertically in this case. Short flex hose connectors such as these are ineffective vibration control devices. Where vibration isolation through the pipe transmission path is required, it is always best, if possible, to use elastomeric flexible connectors instead. So let's consider these cooling water pumps. They are very similar to the condenser water pumps we just reviewed, except they all have flexible metal hose connectors on both the discharge and suction piping. This was a good-looking installation, and I thought it would be a good example of how these connectors are commonly applied. Let's see what we can find and then pause and consider the 5 questions. You can see that all of the connectors appear to be straight and in good condition. Nothing appears to be blatantly wrong. Let's pause and go through the questions. Is there any damage? Nope. These are okay. Are they compressed or stretched or bent or offset? No, they look good and straight. Are they adequately supported? Yes, they appear to be. Are they twisted? The braids look straight, so they're okay. Were the shipping bars removed? Evidently yes, so all these appear installed correctly and therefore okay. Now we're going to switch gears and look at another project with another application of flexible metal hose connectors. In mid-2015, Vibro-Acoustics secured a vibration isolation order for a project in downtown Toronto called the Axiom Condominiums with multiple pieces of equipment and piping. In the penthouse of the East Tower is a water-cooled chiller which is isolated from the structure with various products, including some flexible metal hose connectors. Since this application often gets overlooked, and because I have personal experience with noise problems caused by this issue, I wanted to spend some time discussing it. Here is the chiller drawing from the submittal. Note that there are 4 water pipe connections on a water-cooled chiller. These are easy to find and to select flexible connectors for. On this project, they use single-sphere neoprene rubber connectors. But what often gets overlooked are the refrigerant relief valve connections, which provide safety pressure relief in case of dangerous overpressure conditions. Since the refrigerant can be toxic, it needs to be vented out of the room. Since the chiller is on vibration isolators, any connections need to be flexible, including the vent piping connections to the relief valves. Due to chemical interactions, flexible rubber connectors cannot be used, so flexible metal hoses are the best choice. It should be noted that this is commonly missed by the specifying engineer. The schedule for the chiller called for spring isolators under the unit and flexible rubber connectors, but nothing about flexible metal hose connections for the relief valves. The floor plan for the penthouse level shows the chiller and then includes very specific guidance for the contractor to use flexible rubber connectors for various equipment. The paragraph for the chiller says nothing about the connections with the refrigerant relief valves. So what I think happened is the acoustical engineer on the project identified the need and issued the requirement. Here is the chiller again. We're going to walk around it a bit and then look more closely at the flexible metal hose connectors, which you can see here near the middle of the picture. Starting on the far side of the chiller, we'll walk past the condenser shell and note that the chiller is mounted on springs and any pipes attached have some kind of flexible component to limit the transmission of vibration to the structure. As we noted on the chiller submittal, there are 3 relief valve connections. Here are the 2 1-inch valves on the condenser shell, and walking around to the other side we see the 1 1¼ inch valve on the evaporator side. The tags are still on the hoses, and they remind the contractor to ensure proper installation by following the installation instructions. Good advice, and they seem to have followed it. Let's take a look at the datasheet and installation instructions for these flexible connectors. These are Chamflex hose assemblies made by Chamberlain Rubber Company, and they come in various diameters, lengths, and end conditions. A standard rule of thumb for selecting the length of a flexible metal connector is to multiply the diameter by at least 10. So for a 1 1/4 inch diameter connector, we would select a hose length longer than 14 inches. These hoses appear to be 18 inches long, so they should be okay at reducing vibration through the pipe, especially since they are installed with triple bends. The installation instructions are similar to the FCSS instructions we saw earlier. Here we see that the hoses should not be stretched taut. They should not be in contact with other surfaces that could rub against the wire braided sides. And different from before, these can be bent but should not be bent too tightly. There are minimum bend radii shown in the table corresponding with hose diameter. The hoses used on the chiller are 1 inch and 1 1/4 inch, so we'll want to see that at least 5.5 and 10-inch radii on those respectively. The hoses should be installed without any twisting, one of the reasons why the contractor here used a product that has swivel ends. Figure 4 here helps show what a twisted hose may look like. And over on the second page, we see a couple more examples of things we don't want to see on the job site. The hose should not be bent excessively, and there should not be any damage to the wire braid. So here we see all 3 flexible metal hose connectors. Let's walk through the various checks and determine if these are okay or not. First, are they not stretched taut? All 3 of these clearly have a bend in the middle, so they're okay. Second, are the braids in contact with other surfaces? No, they are clear of everything. Third, do the bend radii meet the minimum requirements? I didn't measure these, but the bends appear to be at least 10 inches for all 3, so they're okay. Fourth, are the hoses free of any twisting? Yes, the braids don't appear to be twisted at all. Fifth, is there any damage to the hoses? No, they look good and clean. So overall, all 3 of these flexible metal hose connectors are okay. So that wraps it up. My final conclusion on this site visit is that the flexible metal hose connectors have been installed in accordance with or close enough to their installation requirements to be okay. In this lesson, we've looked closely at some examples of flexible metal hose connectors, their datasheets and installation instructions, all in the context of performing site inspections to determine if the products have been installed correctly. I hope through this lesson you become more familiar with flexible metal hose connectors and their use.